Ji, Assalamu alaikum. Today we are going to practice differentiation, past paper questions from 2013 to 2022, probably, because the rest of and this is also going to be part of a couple of videos, not a single video. Furthermore, that there are past papers yearly solved for the next remaining of the years for differentiation and obviously the rest of the topics as well. So without wasting any minute, let's start over with the first question. Okay, question is that it is given that f of x, a function, is for all real values of x. Show that f is an increasing function. So let's highlight the important keywords here. If f is an increasing function, which is clear that f of x, f dash of x, the gradient of the function, is always going to be positive, greater than 0. So let's find out the gradient, or let's find out the differentiation of the function. So let's revise the concepts of differentiation as well, which is that the power before the bracket, it comes before the bracket. The power of the bracket comes before the bracket. Then we reduce 1 from the power, which will make it 2. Multiply by the differentiation of the bracket. If you look at the bracket, the differentiation of the bracket is just simple 2. So multiply by 2. This whole complete is the differentiation of the first portion of the function. Further, plus x. So I hope you remember from your IGCSE as well that if you do the differentiation of single x, it's always 1. Further, let's simplification. F dash of x is 2 times 3, which is 6, bracket 2x minus 5 square plus 1. So how do we know that this is an increasing function? We can see that this portion of the function, the differentiation portion, this is a squared portion. So whichever value of x we are going to substitute, even if it gives you a negative answer, ultimately when it's going to come out of it, it's going to be a positive result because of the square. So f of x is always going to give you a positive result, which means that it is an increasing function. So let me write it over here. F dash of x is greater than 0 for all real values, or you can say all values of x. So f of x is an increasing function. Okay, let's move to the next question, which is from May-June 2013, paper 1-1, and question number 9. A curve has equation y is equals to this and is such that f dash of x is equals to this. So the differentiation of the function is given by using substitution. U is equals to this, or otherwise find the value of x for which the function has stationary points. So the key word over here is stationary points. So I hope you remember from the past IGCSE as well again that stationary points are those points where the derivative or the gradient of the curve is 0. So you can say that dy by dx is 0, or you can also say that f dash of x is 0. So all you need to do is just make this substitution, that is u equals square root of x. So substitute it over there in the above f dash of x. So it will be 3 times u plus 3 divided by u minus 10. Now f dash of x means will be 0 because it's related to the stationary point. So 0 will be equals to 3u plus 3 divided by u minus 10. Now simplification is the only thing required. 3u square plus 3 minus 10u, and it will be equals to 0. Let me make it an equation. 10u plus 3, and it is equals to 0. Now all you need to do is just factorization. 9 and it's 9 and 1, so 3u square minus 9u minus 1u plus 3 equals to 0. So it will be 3u is common, which will give you u minus 3 minus 1, and u minus 3 equals to 0. So u minus 3 and 3u minus 1 equals to 0. The two values of u are going to be 3, and the other value of u will be 1 by 3. But remember, he was not asking you the values of u, he was asking you to find the values of x. So let's go back to the question again, where he was saying that, where we substituted u is equals to 1 by x power 1 by 2. So in order to find x, this power is going to go the other side and it is going to flip there, so it will become u square will be equals to x. So one value of x will be 9, which will be the square of 3, and the other value of x will be 1 divided by 9, which will be the square of the second value. So these are the two values of the stationary point. Okay, let's move forward. Find f double dash of x, and hence or otherwise otherwise determine the nature of each stationary point. So since we need this is the nature of the stationary point, which means that either the stationary point is the maximum or it is the minimum. So simple, we already know the values of the stationary point. One value of the stationary point, let me write it here, is 9, and the other value of x on the stationary point is 1 over 9. And we already have f dash of x. Let me just copy that down here, which is 3x power 1 by 2 plus 3x power negative 1 by 2 minus 10. Let me check. Yes. So in order to find out the nature of the stationary point, what we are going to do is we will find out the second derivative. So f dash of x, f double dash of x, which means the derivative of the derivative. So power will multiply before the variable, so which will give you 3 divided by 2. Then we will reduce 1 from the power, so which will make it x power minus 1 by 2. Negative, let me write it positive so that it's more clearer to you. 3 multiply by minus 1 by 2, power comes before the variable. Then you reduce 1 from the power, which will give you negative 3 by 2. Negative 1, there is a 0 because it's a constant value, and the derivation of a constant value is 0. And since we are interested, let me simplify it. It will be 3 by 2 x power minus 1 by 2 minus 3 by 2 x power minus 3 by 2. We need to see that which of the stationary points is maximum and which of the stationary point is minimum. So let's check which one is maximum and which one is minimum. So let's check for x is equal to 9. Let me reinforce the concept over here, that if the value of the stationary point, if you substitute it in the second derivative, if the value gives the answer greater than 0, it means that that stationary value is the minimum stationary point, minimum value of the graph. And if it gives you the value less than 0, which means that it is going to be the maximum value of the graph. Now let's substitute into the function f double dash of 9. If I find it out, all I need to do is I need to substitute the value in the function above, which is the second derivative, as 9. So it gives you 4 divided by 9, which is a value greater than 0. So Just look at the red portion. If the value of the second derivative is greater than 0, it means that that specific value of x is the minimum stationary point on the graph. So x is equals to 9 is minimum value. Let's see the other one where the value of x is 1 by 9. So if we substitute in the second derivative as 1 over 9, let's see in the same function 1 by 9. Yeah, the answer is negative 36, and negative 36, since it's a value in the negative portion, I mean less than 0, so it means that this is a so it's going to be, so x is equals to 1 by 9 is maximum point on the graph. Now let's move forward. It is given that the curve y is equals to f of x. It passes through this point. Find the value of f of x. Okay, so let's, like we did it in IGCSE back then, that if you have a function given to you and if you find out the differentiation of the function, it gives you f dash of x. I mean, if you find the differentiation. Now since we are going opposite of it, this is known as integration. Integration is when you have the differentiated function, you have the dy by dx, and you want to find out the function itself. Now, so we are going to do the differentiation, in the integration. So let me write it here. The differentiation of the function is 3x power 1 by 2 plus 3x power minus 1 by 2 minus 10. So we'll do integration on both sides. So we are going to do integration on the left side, integration of f dash of x dx, and on the right side it will be integration of the function 1 by 2 plus 3x power minus 1 by 2 minus 10 dx. Now it's simple. When you'll find the integration of the differentiation, it will simply turn out into the f of x function. Now if you look at the next one, you add 1 to the power. So if you add 1 to 1 by 2, it will become 3 by 2. Yeah, so okay, now how to do that? So you just add 1 to the power, divide by the new power. So 3x power 3 by 2 divided by 3 by 2. Always remember, you always divide by the new power. So 3x power 1 by 2, because if you add 1 to negative 1 by 2, it will turn out to be 1 by 2 divided by the new power, which is 1 by 2. And since, if you recall, the differentiation of 10x is 10, so it's exactly the opposite of it, which will be 10x. And I hope you must remember that you are always going to add a constant value whenever you do integration without limits. Now let's move forward and simplify. This 3 and 3 will cancel out, so it will be 2x power 3 by 2 plus 6x power 1 by 2 minus 10x plus k, and this is the function we have. Now we already have the function, but there is an unknown value which is k. So if you go back to the question, it says that there is a point which lies on the function which is 4 and negative 7. 4 is the value of x and negative 7 is the value of f of x. So let's substitute these values over here to find the value of k. So if we simplify 2 bracket 4 power 1.5 plus 6 bracket 4 6 bracket 6 bracket 4 power yeah, this is 12, this is 12, 7 is equals to negative 12 plus k, and the value of k is, yeah, the value of k 4 3 by 2 and 5 10 times 4, so it's negative 7 here. Then you'll take it to the other side, yeah, so it will be negative 7 plus 12, which is going to be the value for k, which is 5. Now you need to just write the function. F of x will be 2x power 3 by 2, 6x power 1 by 2, negative 10x plus 5. So this is the function that was there in the start, for which the derivative or the differentiation was already given. Okay, let's move forward. The volume of the uh, circular cylinder of radius r, circular cylinder of radius r, this is the volume that is given to you, 250 pi centimeter cube. Show that the total surface area of the cylinder is this. So always remember, whatever is given to you, be careful for that. If you have a look in the surface area, let me write down the total surface area for cylinder first. So the total surface area of the cylinder is 2 pi r square plus 2 pi r h. Two circles on the top and the bottom, and there is a curved surface area which is 2 pi r h. If you compare it with the answer, 2 pi r square is definitely the same, but there is one thing that is not there in the total surface area, which is h. So it means that we need to find the value of h, and we need to substitute it in here in the formula. So for that purpose, we are going to use the volume of cylinder that is given to us. Let me use it, volume of cylinder, which is pi r square h. Now 250 pi equals pi, and the radius of the cylinder is r, so the value of h is 250 pi divided by pi r square. So if I simplify pi, then pi will cancel out, and the value of h will be 250 divided by r square. Now we'll just simply substitute this value of h in this formula of total surface area, which will make it 2 pi r square plus 2 times pi times r, bracket the value of h, which is 250 divided by r square. Now we will simplify them, and 2 pi r square plus it will be 500, and there is nothing, pi only, and yes, there is an r left in the denominator. So this is equals to S, the total surface area of the cylinder, and this is what he was asking us to show. Now in the next part he says that given that r can vary, find the stationary value of S. Okay, so since we need to find the stationary value of x, and the r is the thing which is changing, so we basically need to find out ds divided by dr, and since it is we need to find the stationary value, so it means that basically on the specific curve, the value, we need to find out that value where the graph is changing the direction. So we'll put the derivative equals to 0. So let's find out ds by dr, and which will be 4 pi r plus, we'll take r above, so it will become, if I take this r above, it will become r power minus 1. So I'll bring it before that, which will turn out to be 500 times negative 1 pi, and then I'll reduce 1 from the power. Remember, r was power negative 1. When I reduce 1 from the power, it will become r power 2. So ds over dr will be 4 pi r minus 500 pi divided by r square. Yes. So yes, we need to find out the value of r first, so that we can find the stationary value of s. First of all, let's see from where the graph is changing the direction. We need to see the value of r first. So for that, we will put ds over dr equals to 0. So 0 is equals to 4 pi r minus 500 pi divided by r square. So it will be 4 pi r equals 500 pi over r square. This pi and pi is going to cancel out. You will be left with r cube, which will be equal to 500 divided by 4. 500 divided by 4, 125 is the value of r cube. So if you take cube root on both sides, the value of r is going to be 5 centimeters. Now we have the value of r, but remember, we need to find the value of s. We already have the formula for s above, which is s is equals to 2 pi r, which is 5 square, plus 500 pi divided by 5. Yes, 5. So if I simplify, this is going to be 50 pi plus 100 pi. So which is 150 pi. I can write it in decimals. I can 150 pi centimeter square. Okay, let's move forward. Determine the nature of this stationary value. So to find out the nature means either it's going to be maximum value or it's going to be the minimum value. So we are going to find out the second derivative of this. So ds over dr square, which will be 4 pi minus, it will change it to a plus because negative 2 is going to come before the variable, which will make it 1000 pi, and it is going to become r power negative 3. Reduce 1 from the power. So we know that the value of r on the stationary point is 5. All we need to do is just substitute the value of r as 5 over here to see that if the second derivative value is positive or negative. So 1000 times pi times 5 power negative 3, automatically positive. Yeah, so it's going to be 4 pi plus 8 pi. It's going to be 12 pi, the value of second derivative, which means that since it's positive, so it means that the value of the stationary point is minimum. So 5 comma 150 pi is minimum point. Okay, or the minimum value, whatever. Okay, let's move forward to the next question, which says which is from May June 2013, paper 1-3, question number 6. It says the non-zero variables. Okay, remember, these variables are non-zero, x, y, and u. U is this. Given that y is equals to this, find the y plus 3x is equals to 9. Find the stationary value of u. Okay, we need to find out the stationary value of u. So stationary value of u means we need to find du over dx, and we need to substitute it equals to 0 because it is the stationary value. So to find out du, if you look at the function in the question, it says u is equals to x square times y. So there has to be just one variable, which is x, on the right side, and we need to get rid of this y. How can we do that? We have the function in the question, which is this. We can make y the subject, so it will be y equals to 9 minus 3x. Just substitute it here. X square bracket 9 minus 3x, so u will be 9x square minus 3x cube. So this is the function that we have, the one that I just wrote on the right side. This is having variable u, and with respect to x we are going to differentiate it, so there is just one variable x on the right side. Okay, so let's find out du by dx first. So du by dx, it will be 18x minus 3 times 3, 9x square. And since we are interested in finding the stationary value, which will be equal to 0, so if I simplify, 9x is common, and it will be 2 minus x equals 0. So one value of x will be 0 from here, and the other value of x will be 2. So x cannot take the value of 0 because it says non-zero variable, so we will say that this is going to be ignored. So where the value of x is 0, we need to find the stationary value of u. So, and we know that u is equals to 9x square minus 3x cube. So substitute the value of x as 2. So u will be 9 times 4, 36, minus 3 times 8 is the answer 12. So this is the value of, this is the stationary value of u. Now stationary value of u, and determine whether this is the maximum value or this is the minimum value. So in order to check that it's the maximum or the minimum, we are going to find out du over dx square. So that will be derivative of the derivative, which is 18 minus 18x. So 18 minus 18x, we need to check whether this x, where the value of x is 2, is it a maximum value or is it a minimum value? So x is equal to 2. Let's substitute it. So d square u over dx square, 18 minus 36, which will be minus 18. Since it's giving you a negative value, so it means that it's a maximum value. Okay, so if the second derivative is negative, it means that the stationary point is the maximum value. Let's move forward. The next question is from October-November 2013, paper 1-1, question number 8. Let's move forward. Question is that inside lane of a school running track consists of 2 straight sections, each of length x meters, and 2 semicircular sections, each of radius r meters, as shown in the diagram. The straight sections are perpendicular to the diameter. Okay, which means that if you make a line like this is going to be a 90 degree. The straight sections are perpendicular to the diameter of the semicircle section. The perimeter of the inside lane is 400 meters. So which means that the yellow portion that I am highlighting if you add all these lengths, this complete length, this is going to end up to 400 meters. Show that area a meter square of the region enclosed by the inside lane is given by this. Okay, so to find out the area, let me just write it down. The area of shape, I'm sure you must agree with me that area of the shape is one complete circle, which is pi r square, semicircle on the left and semicircle on the right, which makes a complete circle, and a rectangle in the center, which is length times width. If you see there is no length, there is no width, so we basically need to substitute the value of length and width. If you look at the length, that is x, and times the width, if you just have a look on the width is basically this portion. This is the width of the question, and if you agree with me, this is the center of the circle, which I'm marking as O. So the above length portion is also going to be R, and the below portion is also going to be R, which makes a total of 2R. If you just have a look in the area, there is no x over there, so we need to remove this x, and the important thing that is given to us in the question is the perimeter of the lanes, the complete portion. So if you see, the perimeter is the sum of all the outer sides. So for finding out the outer sides, this is also x meters from here up till here. Yeah, and there is one complete circumference of the circle, because one semicircle is on the left and one semicircle is on the right. So I'll say one complete circle, which is 2 pi r, and the other thing is 1x at the top and 1x at the bottom, which makes it 2x. I have to add all the outer sides. So the perimeter is 400, which will be equals to 2 pi r plus 2x. If I simplify, it will be 400 minus 2 pi r, divide that by 2, which will be equals to the value of x. Now if I simplify the value of x by taking 2 common in the numerator, so the value of x will be 200, which will be 200 minus pi r. This will be the value of x. This value of x, we can substitute it into the other area function, which is pi r square, plus it's going to be 200 minus pi r in place of x times 2r. So we multiply and simplify pi r square, plus it will become 400r minus 2 pi r square. So I hope all can see that these are the two like terms. We can simplify them, and it will give you 400r minus pi r square. This is the area of the region enclosed by the track. Let's move forward. The next question is, given that x and r can vary, okay, show that when a has a stationary value, there are no straight sections in the track. Okay, show that when a has stationary values, there are no straight sections in the track. So no straight section in the track. The term no straight section in the track means that there is not going to be any x region in the track. Okay, let's see. Determine whether the stationary value is maximum or a minimum. So we basically need to have dA divided by dr, and we have a already given in the previous part. Let me write the formula, which is 400r minus pi r square, 400r minus pi r square. So if I find out for the stationary value, it's going to be d over dr will be 400 minus 2 by r, and since we know that we are interested in finding the stationary value, so dA over dr will be equals to 0. Let me substitute the value of this thing equals 0, and let me see what is the value of r. So r will be equals to 400 divided by 2 pi, and if you simplify, the value of r is going to be 200 divided by pi. So this is the value of r on the stationary point, but we want to find out the value of we are interested in finding the value of, let's see for the value, what is the value of x, and we can see, yeah, we need to show that a is a stationary point when there is no straight sections, and we know that 2x is equals to 200 minus 200 minus pi r. So it's 200 minus pi r is we just found out that on the stationary value, the value of r, stationary point, the value of r is 200 by pi. If I simplify, we will get to know that the value of x is going to be 0. It's very clear, since x is equals to 0, there are no straight sections. Yeah, and one more thing, determine whether the stationary value is maximum or minimum. So to find out the stationary value being maximum or minimum, we will find the second derivative, which will be 0 minus 2 pi, and the answer will be minus 2 pi, which is a negative answer. So since it's a negative value, which means that the stationary value is maximum. Let's move forward to the next question, which is question number 6 from October-November 2013, paper 1-2, question number 6. In the diagram, S is the point which is 0, 12, yeah, right here, and T is the point 16, 0. This is the T point. The point Q lies on ST between S and T and has coordinates x, y. The point P lies and R lies on the x-axis and the y-axis. Let me write down the coordinates first. For P coordinate, there will be some value of x, and that will be the same as the x coordinate for Q, and the y coordinate will be 0. And similarly for the R, the x coordinate will be 0 and y coordinate will be the same as Q. So it's a rectangle. P, Q, R and S is a rectangle. Show that the area of the rectangle OPQRS is given by this. So it's simple and easy. We know that it's a rectangle. So to find out the area, okay, there is one more thing, one very important thing, and that is these two triangles are similar. Yeah, which two triangles? Let me write them down. Triangle S R and Q is similar to triangle SOT. Yes, so we know that the ratio of the two similar triangles is always same. So ratio of this and that is going to be the same. I hope you will agree. This total length is 12, and this total length is 16. Yes, so if we write the ratio of the two sides, it will be I can say, and this length, let me write this length is going to be y, and similarly this length from here up till here is going to be x, depending on this value and this value. So yeah, so let's write down the length. This is L1 over L2, so that will be 12 minus y divided by 12 of the bigger triangle, and it will be equal to the ratio of the other two corresponding sides, which will be yeah, it will be x divided by 16. So if you simplify, it's going to be if you find the value of y from here, it will be 12 minus y, which will be equals to yeah, it will be 12 divided by 16x. So if I find y, and y will be equals to 12 minus, it will simplify as 3 over 4x. Now why did I make the subject y? Because there is no y in the question. Now I have y and I have x, so to find out the area of the rectangle, the formula is area length times width. The length is x and the width is 12 minus 3 by 4x, which is 12x minus 3 by 4x squared. This is the area of the rectangle PQR, sorry, not S. Okay, let's move forward. Second part, given that x can vary, find the stationary value of a. So stationary value of a means that we need to find dA divided by dx, and we are going to substitute it equals to 0. So to find out dA over dx, let me see the function. The function is right here at the end. This is the function. I'll find the derivative, which is 12 minus 3 by 4 times 2 x power 1. If I simplify, this is going to be 12 minus 3 by 2 x. Now we know that it has to be equals to 0 because we are finding the stationary value. So it will be 12 equals to 3 by 2 x, and if I simplify, x will be 24 divided by 3, which gives you the value of x as 8. So but we need to find a, the value of the stationary value at a of a. So it will be 12 times 8 minus 3 by 4 bracket 8 square. So 64 times 0.75. So 12 times 8 minus this, which is the area, which is a area of the stationary value, which is 48. Yes, 48. Now we need to know that the nature. Is it a maximum value or is it a minimum? We'll find the second derivative of the derivative, which will be 0 minus 3 by 2. So 0 minus 3 by 2 is minus 3 by 2. So this is just so it's simple, since the second derivative is negative, so it's the maximum value. Let me write, since d square or a over dx square, since it is less than 0, so maximum value. Let's move to the next question, which is question 7 from October-November 2018. that is paper 1-3 and question number 9. A curve has equation y is equals to this. This is the equation for the curve where k is a positive constant. Yes, the value of k is positive. Find in terms of k the value of x for which the curve has. Find in terms of k the values of x for which the curve has stationary points. So we are basically interested in the stationary points, and we also need to determine that whether the stationary points are going to be maximum or they are going to be minimum. So in order to find out stationary point, basically we need to find out dy over dx, and it has to be equals to 0. So let's find out the values first. If we find for finding the derivative, let me bring the functions in the numerator. It will be x plus 2 whole power minus 1 plus x. This is going to be the function for which I am going to do the differentiation. So it will be dy by dx. How do we do the differentiation? We bring the power before the bracket, so k square will remain as it is, multiply by the power of the bracket, which is -1. Then we are going to reduce 1 from the power, which is going to make it -2, multiply by differentiation of the bracket. Just this yellow portion of the bracket, the differentiation of this yellow portion is +1, because the derivative for 2 is 0 and the derivative of x is 1, plus the differentiation of x is 1. So if I simplify and write it in the simplified form, it will be -k square divided by x plus 2 whole square plus 1. This is the dy by dx, and since we are interested in finding the value of the stationary value, basically values of x, so we are going to substitute dy by dx 0, so which will be yes, it will be simplification, so it will be -1 equals to -k square divided by x plus 2 whole square. Negative and negative will cancel out. This bracket is going to go to the other side. It will multiply, and it will become x plus 2 whole square, and it will be equals to k square. Now if I simplify it, yeah, if I simplify, for simplification I have to take square root on both sides. So if I take square root on both sides, the k is going to there are going to be two values for k, one positive and the other negative. But in the question, I think, yeah, he says that k is a positive number constant, so we are going to ignore the value for k being negative. So the value of x will be k minus 2. Yeah, but k is negative. Yeah, but k is negative. It can give you a positive result when if you subtract 2. Find in terms of values of x. So you're going to find for both of them. So it will be minus k minus 2. Yeah. So these are the two values of the stationary points. These are the two values of x for the stationary point. Yeah, we need to find the nature. To find the nature, we'll find the derivative of the derivative. So let me take it from here. It will be d square y over dx square. Let me simplify and write it over here. Minus k square bracket x plus 2 whole power minus 2 plus 1. This is the easiest, simplest form of derivative. If I find the derivative of this, it will be -2 x plus 2 whole power of minus 3 and times 1, because the derivative of that is 1. And simple. So, and yeah, the derivative of 1 is 0. So what is the derivative? Second derivative, I mean, d square y over dx square, which will be 2k square divided by x plus 2 whole power of 3. Now we can see for the values, two values of x, we have the two values of x over here. Yeah, we have the two values of x. Yeah, the values of x are, then the value of x is k minus 2. All we need to do is just need to do the substitution here in the derivative, which will be d square y over dx square 2k square divided by bracket k minus 2 plus 2 whole cube. They will cancel out and it will be 2k square divided by k cube. If you simplify, it will be 2 divided by k, and 2 divided by k, and since we know that the value of k is always going to be a positive constant, so 2 divided by any positive answer, it's always going to result into a positive. So since this d square y over dx square is greater than 0 for this, so x is equals to k minus 2. This is going to be a positive value, so it's going to be a minimum value. This is going to be a minimum value. Similarly, we are going to do the same for the value of x. For the value of x is equals to, let me write it here, the same value of this, so it will substitute y over dx square. So if I substitute, it is going to be 2k square divided by bracket negative k negative 2 plus 2 cube. Okay, so k square divided by negative k cube. So if you simplify, it will be 2 divided by negative k. So if you are dividing a positive result by a negative number, so it means that this is going to be a maximum value. Let's move to the next question, which is question number 8, May June 2014, paper 1-1, question number 4. It says that a curve has the equation y is equals to this. So equation of the tangent. So equation of the tangent is a straight line at the point where the line x is equals to minus 1 intersects the curve. So it's basically we need to find out dy by dx to have the gradient of that respective point, which is x is equals to minus 1. We need to find out the equation of the straight line. So for finding out equation of the straight line, we need to have two things. One is the value of one is the gradient, and the other is the coordinates of the point. So it will be, for finding the gradient, I'll bring this into the power, and let me find out dy by dx first, and the dy by dx will be 4 bracket negative 2 bracket 3x plus 1, and then I will reduce 1 from the power, which will make it x power minus 3, multiply by the derivative of the bracket, which is this yellow portion. So the derivative of this bracket is 3, which is going to be minus 8 times 3, which is negative 24, divided by 3x plus 1, and its whole power is 3. So we know that we need to find out the gradient dy by dx, where the value of x is supposed to be minus 1. Let's substitute the value of x being minus 1 here. So it's going to be negative 24. It's negative 3 plus 1 to the power of 3. The answer of the gradient is 3. And other thing is that we need to know the coordinates of the point. So for finding out the coordinates, we already have the x coordinate. We just need to find the y coordinate at where the value of x is minus 1. So it will be 4 divided by negative 3 plus 1. Yeah, so it will be, the value of a y is also 1, so the coordinates are -1 and +1. So equation of a line is y minus y1 equals m into x minus x1. So y minus y1 is, remember, this is x1, this is y1, and this is the gradient. This is the value for m. Substitute them here. X minus -1, which is going to turn into a +1. So y is equals to 3x plus 3 plus 1. So y is equals to 3x plus 4. This is the equation of the tangent to the curve at x is equals to -1. Let's move forward to the next question, which is question number 9 from May-June 2018. May-June 2014, paper 1-1, question number 12. It says that dy by dx is given to you, and he is asking you to find out the equation of the curve. So to find out the equation of the curve, we just discussed earlier, we'll do integration on both sides. Integration of x power 1 by 2 minus x power minus 1 by 2 dx. So this is going to convert into y, and this is going to be, if you add 1 to the power of this, it will become 3 by 2, and then you'll divide by 3 by 2, x power 1 by 2, and you will divide by 1 by 2. But remember, you are going to add a constant in the end. So how to find out this constant value? But before that, let me simplify. It will be 2 divided by 3, x power 3 by 2 minus 2, x power 1 by 2 plus k. This will be the equation of the function that was there, for which dy by dx was given. He said that it is having, the curve has a point which is 4, 2 by 3. Let me substitute it here to find the value of k. 2 divided by 3, 4 power, sorry, it's 2 by 3 here, 3 by 2 minus 2 bracket 2 by 3 plus k. Now if you simplify, this is going to be 4 to the power of 1.5 times 2 times 2 by 3, 16 by 3, so 16 by 3 minus 2 bracket 2 by 3 power 0.5. Yeah, so this portion is so if you simplify this is and bring this k to this side, so the value of k is going to be minus 2 by 3. So to write down the function, it's going to be y is equal to 2 divided by 3 by 2, 2x power 1 by k minus 2 divided by 3. This will be the function f of x. Now we need to find out the second derivative, which is of this derivative. So that's very simple and easy. So d square y over dx square, it will be 1 by 2 x power minus 1 by 2, then plus 1 by 2 x power minus 3 by 2. Find the coordinates of the stationary point and determine the nature. So to find out the stationary points, it's dy by dx, and we will substitute it equals to 0, which was already given. So x power 1 by 2, x power 1 by 2 minus x power minus 1 by 2, and we are going to substitute it equals to 0. So if I simplify, it will be x power 1 by 2 equals to x power negative 1 by 2. So if I simplify it further and further simplify, it will be if I take square on both sides, it will be x is equals to this. It will, if I further simplify, yeah, so it will be x times x square, which will be equals to 1. So the value of x is going to be 1. So this is find the coordinates of the stationary points. So this is one value of stationary point, so which is x is equals to 1. So I have to check coordinates. Yeah, so to find out the coordinates, I have to substitute this x is equals to 1 in the function, which is we just found out 2 divided by 3 bracket 1 power 3 by 2 minus 2 bracket 1 power 1 by 2 minus 2 by 3. So y is equals to, it will be 2 by 3 minus 2 minus, so it will be the value of, yeah, it's y is equals to minus 2, because this and this thing will cancel out automatically, will be left with y. So the coordinate of the stationary point is 1 comma minus 2. These are the coordinates of the stationary point. And after that, we need to determine the nature. For the nature, we will use the second derivative, which we already found in the previous part. So let's substitute the value of x in here. So if I substitute the value of x, which is 1, so it will be 1 plus 1 by 2, which is going to be, sorry, 1 by 2 plus 1 by 2, yeah, it's going to be 1. Since it's a positive result, it's a greater than 0. The second derivative is greater than 0, so it means that this is the minimum value. The stationary point is the minimum value. I hope if the things are clear so far. So for May June 2014, next question we are going to start in the next video. If there is any query, please let me know in the comment section, and if you like and understood the questions well, please don't forget to share it with your friends, and don't forget to subscribe the channel, and definitely it's going to benefit me, as well as when you'll share it with your friends, it's going to help them as well. So see you in the next video. Thank you. Allah Hafiz.